Hi everyone, welcome to my presentation of the peer graded assignments under the Machine Learning Foundations for Product Managers course. Right, so let's just get into it. Right, so for the background, we are looking at exploring and creating a model, right, to predict the full load output power for a combined cycle power plant. So the combined cycle power plant is dependent on a number of parameters, which include the atmospheric pressure, the exhaust steam pressure, the ambient temperature, and the relative humidity. So basically, what we are doing is we are looking at all these parameters, and we are trying to use them to predict the full load output power of the combined cycle power plants. Right. So to the objectives. Right. So the objective is to develop a predictive model to predict the full load power outputs and also evaluate the performance of this model that we've built using different evaluation metrics. Now, to the workflow, we are going to be following four steps in this presentation. Exploratory data analysis. We're going to develop the model. We're also going to evaluate the model and select the best model based on our evaluation. So, to the exploratory data analysis, a data set was given to us, which I downloaded into Jupyter Notebook, Python Jupyter Notebook using Python, and checking the information on the data. I observed that there are 5 columns and 9,568 rows for each of these columns. So we have HC, V, atmospheric pressure, relative humidity, and we also have the electrical output column, which is the target variable. Yeah. So the next thing is data distribution. So I also looked at the data distribution. I checked the counts for each column, the mean, the standard deviation, the minimum value, the percentiles, and also the maximum value. So I checked that too, the data distribution. Then the next thing I did is to draw up a correlation, check the correlation among between each column and also against the target variable. And the target variable is PE, which is the electrical output, right? And what I observed is that there is a strong correlation between 8C and PE, which is the electrical output, although it's a strongly negative correlation, but there's actually correlation, right? And I also observed that there's also a strong correlation between 8C and V, right? Which might cause problems for us. Problem of multicollinearity, which is presently my conclusion. So the way to solve this problem is to pick a feature that's which is 8C. That strongly correlates with the target variable, that is PE. Or we can just live with the problem like that. So right. So I did go with the first option, which is to pick 8C and use alongside the target variable PE. Right. So the next step is to develop the model. And developing the model, I used 3 models: linear regression, decision tree regressor, and the random forest regressor as well. Right. So after creating these models, the next thing I did was to evaluate the model. So I used 3 evaluation parameters or metrics, which is the root mean square error, the R squared, and also the mean absolute error. So I did this for each of the models. So the one on the screen right now is the linear regression, right? And I found the root mean square error, the R squared, and also the mean absolute error, which you can see. The root mean square error is 5.2, the R squared is 0.9, and the mean absolute error is 4.17. For the decision tree regressor, the root mean squared error is 5.9. The R squared is 0.87, and the mean absolute error is in the range of 4.6334. So for the random forest regressor, I also found the root mean square error to be 5.6788, the R squared to be 0.8897, and also the mean absolute error to be 4.4438. Right, so on selecting the best model, the linear regression seemed to be the best model because it had the highest R squared value and also the lowest root mean squared error value at 5.2 for the root mean squared error and 0.9 for the R squared value. So what we are targeting in our model is the model with the highest R squared value and the model with the lowest root mean squared error. So we'll be going with the linear regression model to predict our electrical outputs for this project. Yeah, so thank you so much for listening.